Thank you very much for allowing me to give this presentation. So, uh, so here is basically the punchline of what I will be talking about. So there is a lot of talk about realism in quantum mechanics, but what I will try to argue is that many who call themselves realists actually have just stopped worrying and have been seduced by quantum mechanics too much, even from their own point of view. In particular, the idea that I will try to defend is that the measurement problem, which is the problem that usually realists about quantum mechanics think needs to be solved, is actually not a problem for the realist, but it's a problem for the instrumentalist. And actually, what I will argue is that the realist should have never considered it. So this should be a much longer talk, so you will have to forgive me if I skip on some of the details. But in order to grasp what I mean, and in order to argue for my point, I will distinguish between three different kinds of scientific realism that I'm not sure. I mean, now that I've listened to the first talk, the talk before mine, I'm not. I mean, I will use some of the very same terminology, weak realism, strong realism, but I'm not sure they actually connect in the very same way. So there is this a robust kind of realism, a more relaxed realism, and then there is an hybrid. These are, the type of realism that different approaches to the ontology of quantum mechanics seem to be endorsing. So when people are proposing their metaphysical views about what quantum theory teaches us about the nature of the world, they're actually endorsing different type of realism. And I will argue that if you're a robust realism, then there are reasons for you not to have considered the measurement problem. If you are another, and that's also true for the other types of realism. So let me start at the very beginning. So quantum theory. So if you go to the Copenhagen view of quantum mechanics, the basic idea is that quantum theory is not able to provide you with any microscopic description of the world. It just gives you a recipe for predicting experimental results. And as such is incompatible with scientific realism, which is instead, very roughly speaking, the view that theories can give us information about the nature of reality. So let's call it the realism problem. Traditionally, this problem has been taken to be identical with the measurement problem, namely the problem of eliminating precisely the macroscopic superpositions that the theory predicts, right? So namely, if you can solve the measurement problem, then you can regard quantum theory from the point of view of scientific realism. However, if you actually look about what's going on, there seems to be no unique way of thinking what exactly is the incompatibility between quantum theory and scientific realism. And indeed, different people find the problem to be a different problem. So, I mean, when you look at the orthodox theory, right, the one that you find in physics books, you have the wave function, and that, as you all know, it's a linear evolution, right? And so there are superpositions, and so of course there is a problem that you can call the measurement problem, which is just in this instance only a problem of empirical adequacy, right? If the wave function describes everything and it evolves linearly according to the Schrödinger equation, then measurement will have no definite results, right? Because the superposition of all possible results is also a possible result, right? However, we never observe more than one result for each experiment. And in this way, so the theory predicts A, we don't observe A, so we have to do something, right? I mean, just to to make the theory empirically adequate. And of course, the traditional way out of that is to have the collapse rule provided by von Neumann, that when a measurement is performed, the wave function collapses in one of the terms of the superposition. Of course, many people find this totally unsatisfactory. Complaint that have been raised is that it's unclear when one is supposed to apply it. What is a measurement? What is an observer? Okay, so there are two dynamics, one that is supposed to apply to microscopic objects, you know, and the other one which is supposed to apply to measurement apparatuses. So some people, I mean, usually people that claim to be realists, think that the real problem that needs to be solved is a problem of precision. Okay, and that's what they have in mind when they talk about the measurement problem. We need to eliminate the macroscopic superposition precisely using a rule which does not rely on the notion of observer or measurement. And of course, this corresponds to the three traditional solutions of the measurement problem, namely the many-word theory, the pilot wave theory, and stochastic collapse theories. However, if you look to history, you will see that there are other possibilities, right? There is another one distinctively, namely that the realism problem, namely the problem of incompatibility between quantum theory and scientific realism, lies in the idea that quantum theory is fundamentally incomplete, as it is a theory of the wave function, which is not suitable to describe a physical field. So the measurement problem, like the cat problem, is usually tracked down to the 1935 paper by Schrödinger. But actually, quantum mechanics was people believe that quantum mechanics was conceptually problematic much earlier than that. If you go back to the 20s, 1926, at the time of the Solvay conference, people were debating about the meaning of the theory. There was matrix mechanics and wave mechanics. Lorentz complained that he would not be obliged. He was very excited about the Schrödinger picture, the Schrödinger wave mechanics, but then he wrote in a letter that he felt obliged to go back to matrix mechanics, which is totally not, I mean, according to him, was not okay, because it was not, you know, Schrödinger's was better because Schrödinger could actually provide a pictorial view about what was going on, waves, you know, as opposed to matrices, right? However, he complained and said, look, I mean, Schrödinger, I would have to go back to Heisenberg, right, if you could not solve this problem. What problem? Well, the fact that for a many particle system, the wave function is not in three-dimensional space, but it is in a high-dimensional space. Okay, and this was considered by Lorentz, by Einstein, by and ultimately also by Schrödinger, unacceptable. I feel like that cannot represent a physical field. It's very different from an electromagnetic field because it's not in three-dimensional physical space. So if you believe that's true, like they did, then you need to complete quantum mechanics with something else other than the wave function. So there seem to be three problems of realism, three ways of understanding what it means that quantum theory is incompatible with scientific realism, which correspond to three different kinds of problems that we need to address. One is the problem of empirical adequacy, whose solution is provided by the von Neumann wave function collapse. And then another one is the precision problem, what is traditionally intended by most scientific realists as the measurement problem. And we have these three solutions. And then we have the completeness problem that I just talked about. The solutions, I mean, let me talk about later about what the solution of that could be. So it seems to me that depending on, so which of the three measurement problems should be interest of the scientific realist depends on what type of scientific realist you are. Okay, so at least there are these two broad ways of understanding scientific realism. One is in a relaxed way, and another one is the robust way. in a relaxed way or in a weak way, a theory, you are a relaxed realist if you believe that a theory is amenable to a realist interpretation. Sorry, a theory is amenable to a realist interpretation if it is able to account for the macroscopic regularities. So if you're able to, you know, systematize the phenomenon in a certain way. A robust kind of realism, a strong kind of realism instead thinks it requires more. A theory is amenable to a realist interpretation in this way if it is able to provide a fundamental, dynamical, microscopic explanation of why such regularities happen. Okay. So the robust realism may be tracked down to many people. It seems to me that Einstein could be taken to be of a realist of this sort. He was convinced that quantum mechanics was incomplete since the 20s, and it was because of this reason that he thought it is incompatible with realism, and he provided various reasons, right? Various arguments in temporal order starting from 26 to 35. First, the configuration space problem, that the one that I mentioned earlier, that Lorentz pointed out. If quantum mechanics were complete, then the wave function would be a wave in configuration space, which cannot be, okay, and that's unacceptable. Also, the non-locality argument, the EPR argument, was an argument of incompleteness. If quantum theory were incomplete, then the world would be non-local, and that is unacceptable. Okay, forget about the fact that it didn't work out, but that's what he wanted to provide, an incompleteness argument. Schrödinger's cat, which is actually was actually suggested to Schrödinger in Einstein in a letter that, I could find the reference. If quantum mechanics were complete, then we would have macroscopic superposition, and that is unacceptable. This view, right, to point out that you have this incompleteness, right, seems to suggest that he was a robust realist. He was looking for something to account for the microscopic dynamics to explain why the quantum rules actually work, right? Why do you have the experimental results that you have? Both Einstein and Schrödinger wanted to make quantum mechanics compatible with scientific realism by providing this fundamental microscopic description rather than merely suppress the macroscopic superposition. For them, it was not enough, right, to just say, well, you have to, we don't observe, right, the cat both dead and alive, so just suppress one, right? And so there is a sense in which the spontaneous localization theory and the many-word theory would not be an option for them, right? And instead, a relaxed realist would not necessarily look for any additional information to complete description of the wave function, right? So the spontaneous localization theory and the many-word theory, in which the only thing that there is the wave function, right, were never an option for Einstein's because, Einstein's believed that the wave function, and Schrödinger did as well, could not be the whole story. That's not what the relaxed realists think. They say, no, right? So let me try to characterize relaxed realism in more detail a little bit. So traditionally, realism is contrasted with instrumentalism. While instrumentalists care only about reproducing experimental outcomes, realists instead care about understanding, right, the nature of reality, which gives rise to such outcomes. Realists also advocates that one needs to solve the precision problem in order to have information about the nature of reality from quantum theory, right? Usually, if you are a realist about quantum mechanics, you start with the discussion with, we need to solve the measurement problem. We need to precisely eliminate macroscopic superpositions. However, in the literature, you find people who call themselves realists without seeing any need of solving the measurement problem as we intended, the precision problem. They think the problem is merely the one of empirical adequacy, and therefore they find nothing wrong with the solution provided by von Neumann. They take the orthodox views at face value, right? Say, just take quantum mechanics and von Neumann, and then they try to make really sense out of it, right? They can be thought of as a radical variety of the class that I've dubbed relaxed realist. So robust realist, the one that they say, oh, quantum mechanics is incomplete. Then you have relaxed realist. In general, they say, no, right? It is complete. And then you distinguish the relaxed realists between the radical and the non-radical. The radical are the ones that say, I don't find a problem with the von Neumann collapse rule. These people are example of what I mean when I'm thinking about radical relaxed realism. Informational theoretic interpretation by Bobin-Pitofsky, or for example, reinforced realism, again by Vladimir and Ross, right? So this, the basic idea, for example, of the information theoretic interpretation of quantum theory is that the quantum mechanics can be understood as laying out a set of constraints imposed on the empirical data. They explicitly say about themselves that they are realist, right? They say the data exist objectively and mind independently, and they think that they don't need any additional story about how these data are generated, okay? So the idea is that we are realist, right? But about something, you know, macroscopic, namely this data, right? And that's it. We don't need more. We are realist anyway, okay? Let me skip over reinforced realism, just focus on one example. So usually the reaction from the realist camp is that, no, you're just being borderline instrumentalist. That's not what a realist should be. That's not enough. Okay, however, I mean, the radical relaxed realists will not deny that physical theories are not the kind of things that can give us a description of the unobservable. They think instead that the microscopic description is not needed to make the explanation satisfactory. So that's why I call them radical, because they're really borderline instrumentalist and not enough for many people. So, and then of course there are the one in the middle, right? They are not robust realists, because robust realists are those who believe that quantum theory, in the terminology that I came up with, the one that believe that quantum mechanics is incomplete. They're realist, and they're in a relaxed way. They're not radical because they believe that providing a systematization of the data, a constraint of the data is not enough. So let's call them moderate, okay? These people ask for more than the radical relaxed realist, for more than just systematization of the data, but they don't want to go robust. So they could still care about the adequacy of adequately reproducing the phenomena, but they could also care about having all physical objects and processes being governed by a unified, precise dynamics, okay? So while for the radical relaxed realist, we just saw the realist problem, the problem of incompatibility, seen as the adequacy problem dissolves when adopting the collapse rules. For these people, right, for this variety of non-radical or moderate relaxed realist, there is still the problem of precision, right? They don't, they want to suppress the macroscopic superposition precisely with the precise dynamics. They don't want two dynamics. This is a realist account, but still relaxed because it deals with the phenomena at the macroscopic level and does not question the wave function to be complete. Okay, so this is most people, okay? Because most people take the three solutions of the measurement problem seriously. However, this is a very, very, very peculiar position to hold. At least that's what I think. How did the realists end up focusing on the phenomena, macroscopic superposition, and not the microscopic dynamics? Instrumentalists care about these things. So shouldn't the realists care for more? And indeed, this is the position of the robust realist, right? Who cares about more than just eliminating macroscopic superposition. She looked for the microscopic dynamics, which generates what we observe at the macroscopic level. She uses the measurement problem to make the point that quantum mechanics is fundamentally, incomplete, not complete, rather than to claim that this is enough to eliminate the macroscopic superposition. So now the question is, why think that the measurement problem is the realist problem? Why think that the measurement problem is the real problem a realist should solve? So there is a sense in which I think the measurement problem is fundamentally a problem, if it is a problem at all, not with two L's, right, for the instrumentalist rather than for the realist. And this is somewhat paradoxical because it is the realist who brings up the measurement problem as the problem of quantum theory. And of course, I mean, the fact that the measurement problem is an instrumentalist problem is clear from the name, right? It is a problem of which measurement outcomes we could observe, not a problem about why we observe them. We do not worry about what kind of microscopic description could give rise to such macroscopic measurement outcomes. So summing up, it seems we can write down this table. If you're a robust realist, your problem is completeness or incompleteness, and that's what the primitive ontologists end up doing. If you're not radical, relaxed realist, your problem is the precision problem, precisely eliminate macroscopic superposition, and this is what are the usual solution, hidden variables, modified Schrodinger dynamics, and many words. If instead you are a relaxed realist, your problem is just to make sense of, to make quantum theory empirically adequate, and that's can be done by the von Neumann rule. Okay, so if you do not think that this is real, I mean, the radical relaxed realists are realist enough, that's okay, right? They think of themselves as realists, but I mean, I think that this classification is helpful. At least it was helpful to me when I was because I was trying to understand why people are disagreeing so vastly, right? And so maybe it is because, right, they have a different understanding of what is the problem, what kind of, what is it, and because in that way we end up to endorse a different solution. So there is this view in the literature which is called wave function realism. So traditionally, we have many words in GRW as been proposed by solution of the precision problem, namely the measurement problem as properly intended, usually intended. They are theory about the wave function, that is a fundamental equation. Because they are theory about the wave function, and because the wave function is the object that the fundamental equation of this theory is about, the wave function is the fundamental object of the theory, right? We should be realist about the wave function. This is a preliminary argument for wave function realism. Just like one was a realist about position in classical mechanics, because the fundamental equation of classical mechanics was an equation of the temporal evolution of position. So one could have in the case of many words in GRW, right? So wave function realism says that the metaphysics is provided, the ontology is provided by the wave function, at least in many words in GRW. So, okay, which type of realists are many words theorists? Well, they are relaxed realists, right? Of course, right? The main idea of many words is that there are macroscopic superpositions, but we do not see them because the different terms of superposition never interact with one another. The alternative outcomes of the measurement process are associated with different branches of the decomposition of the wave function. The basic problem the many word theory solves is the appearances, right? It saves the appearances. The theory needs to explain how measurements have definite results, and its reply is that they do not. What about collapse theories? And natural possibilities, again, wave function realism, what people have been calling bare GRW or GRW0, a theory according to which everything is the wave function. since the wave function is again in configuration space, in this high dimensional space, this theory is not a solution of the completeness problem. That's why Einstein, for instance, I mean, I don't know. I mean, I can't talk for Einstein, but I mean, a robust realist would not consider that as satisfactory. And so it's not, if you are a bare GRW theorist, then you cannot be a robust realist, right? And indeed, the wave function realist needs to derive the appearances again of three-dimensionality, of localization and regular macroscopic properties in terms of the wave function, just like in the case of the many-word theory. So how do they do this? Well, there are two proponents, at least, that I know of. One is David Albert's functionalist reduction approach, and the other one is the one by Ney, who proposes that an account based on symmetries. So the idea is that, I'm not going to go into detail about this, but what they want to do is that everything is the wave function. Okay, the wave function is this high configuration space. Okay, but we have to recover the appearances of three-dimensionality. It seems that there is a pen here, this pen appears to be a three-dimensional object, blah, blah, blah. So how do we do that? They provide strategies to recover the appearances. They say, well, we can, for example, in Albert's case, he says, well, we can define three-dimensional microscopic objects functionally with functional analysis. They provide principles of functional analysis to recover these appearances. Again, this to me suggests that wave function realists are relaxed realists in denial because they think of themselves as being robust realists in the sense that they call themselves wave function realism because they take the wave function ontologically seriously. They wanna provide a picture about the word. However, they end up endorsing a position which to me looks too similar to the relaxed realists, right? The information theoretical guys that they would arguably like. They reproduce the appearances and systematize the phenomena just like they do, right? All right, let me skip that. Just briefly, many wave function realists think that the pilot wave theory is not very compatible with their ontology because that would be, run into all these kind of problems. For example, in either you think of that as n particles in three-dimensional space and one wave in 3n-dimensional space, or one quote particle and one wave all in 3n dimensional space, and they're both problematical. So they don't think that pilot wave theories are a good fit for their approach. A better way of understanding pilot wave theories is the primitive ontology approach, according to which the pilot wave theory in particular, but it's a general approach, is about particles in 3 dimensions, and the wave function instead does not represent matter. The underlying assumption of this approach is that the realism problem is the incompleteness problem. One always needs an ontology represented by a mathematical object in 3-dimensional space because, given that the wave function is a field in configuration space, it cannot represent the ontology of quantum theory. Therefore, all quantum theory are incomplete, right? They all should be thought as, quote, hidden variable theory in the sense that matter needs to be described by something else in 3-dimensional space and not the wave function. So I take to be our approach to be trying to solve this very problem, not only the precision problem. So, but if you grant the
sorry interrupting you. You have 5 minutes.
All right, thank you. So if you grant the quantum theory is incomplete, then you can complete it however you want. Okay, and arguably the simplest way is doing that with positions, right? And like in the case of the pilot wave, you have deterministic evolution for both position and for the wave function, but you can go at different ways, like the different proposals, GRWM, GRWF, GRW with positions. They're all solutions of the realist problem seen as the incompleteness problem, not the measurement problem. Okay, so if you focus on the measurement problem, you don't see why you need the primitive ontology. So in this 5 more minutes, let me just go and try to connect what kind of realism, why different people have different, why different people think of realism in different ways. I think that I have connection, I connect this with the type of explanation someone finds satisfactory. And in order to make the point, I find the distinction, again, provided by Einstein between principle and constructive theory helpful. According to Einstein, principle theories are formulated in terms of principles which are used as constraint on physical possible processes, as for example in thermodynamics. So you say, here are the principles, right? Data cannot violate these principles, right? Instead, there are constructive theories which involve more than that, right? A dynamical reduction of macroscopic objects in terms of the motion and interaction of their macroscopic constituents, right? So if thermodynamics is a principle theory, kinetic theory is a constructive theory. Oops. All right. Hold on. Okay. Robust realists would favor constructing theory. Because theory would regard the realist problem to be the completeness problem. A radical relaxed realist would instead, so the two at the sides would instead favor principle theory and would regard the realist problem as the precision problem. What about the ones in the middle? The ones in the middles, they're a hybrid. They claim that to be robust realists, as they wish to find an understanding on the fundamental reality, but if so, they should propose a constructive theory. And this would require a dynamical derivation of the quantum rules in terms of the fundamental ontology. But instead, the explanation of the macroscopic phenomena is fundamentally non-constructive. They provide principle, right, that constrain the phenomena. For example, Albert constrained them by postulating the Hamiltonian needs to be such and such. Okay. Or functional analysis or something. However, so you see, are they principle theories then? Well, no, because they do care about the dynamics. The precision problem motivated to have a precise equation for the dynamics in all scales, right? So, so they end up having a non-constructive explanation and giving importance to the dynamics, right? They provide a non-constructive explanation and they give importance to the dynamics, but they pull in opposite direction, right? One pulls towards relaxed realism and the other pulls towards robust realism. So we do have the hybrid right there, right here. Non-constructive explanation, but importance to the dynamics. Radical relaxed realism, what should you say? So let's just go back for a second, and this should be my concluding slides, if I'm not totally mistaken. All right, so the radical relaxed realist, like the information theoretical approach, to say, okay, right, we just need to constraining and systematizing the phenomena, right? So we just focus on the adequacy problem, and the measurement problem is just something that we don't need to worry about, right? For Neumann, collapse rule is fine. The robust realists say, no, we want, you know, we endorse a robust version of realist. But if so, why do we even look at the measurement problem, right? At the end of the day, the measurement problem allows for solutions that are unsatisfactory, because the real problem is the configuration space problem, right? The real problem is the wave function shouldn't be allowed to be part of the ontology because it doesn't make sense of a field in configuration space, right? So a robust really should think that quantum mechanics is just like thermodynamics, as we need to complete, right? But if so, again, this theory should not have been considered the robust, this theory, I mean, the many word theory and and the spontaneous collapse theory solution of the measurement problem are never enough, right? And that's why we propose the GRWX or GRWF or whatever, right? Or SM or SF, but they're not realists enough. So they're realist enough, but they're solution of the measurement problem. So if you focus on the measurement problem, you don't understand why you need this additional stuff. The one in the middles, right? They just say, okay, right? The wave function realist, and yeah, I think I'm almost done, right? They have a tension between the desire of providing explanation, right? But there is a desire of the wave function realist of robust realism and the kind of explanation the theory provides, which is not constructing there. So she starts off as a robust realist, but she ends up too close to the relaxed realist approach that she would presumably like, right? So the point, what was the point of solving the measurement problem if you can actually solve it as the information theoretical people do, right? Arguably, you want to say, no, you don't understand. It's because of the dynamics, right? But if you care about the dynamic, right, why are you providing non-dynamical explanation would be my question. So I have tried to argue very quickly. I realized that the measurement problem is a red herring. It has been proposed by realists to reconcile quantum mechanics with scientific realism, but it would have been, should never have been considered by realists at all. By focus on this problem, I think, just created a vast amount of confusion, and this prevented scientific process. If you are a relaxed realist, radical form, you should be happy with the von Neumann rule. If you're a robust realist, right, like the primitive ontologist, you should focus on the completion of quantum theory, right? So there is a sense, and of course, I mean, a huge parenthesis should be added about the value that other theories can provide, but as far as the compatibility with realism is concerned, people of this sort should never focus on the other solution of the measurement problem other than hidden variable type. If you are a non-radical relaxed realist, like the wave function realist, it's kind of unclear to me why you should focus on what you should focus on. If you care about principle explanations, right, you should not care about the measurement problem, but only the adequacy problem, right? Like the IT person. If you care about the dynamics, then you should care about the completeness problem. All right, so thank you. Let me just wrap up the, okay, now I don't know what I'm doing anymore. I lost. Can you still see me?
Yes, of course.
All right,
yes,
okay, so let me just wrap up in a sentence what I was trying to do. So it is, I think that one should distinguish about different types of realists. These different types of realists are tied to different types of explanatory structures, and these explanatory structures can help people identify the reasons why they prefer one theory over another theory, which is not some, if you just focus on the measurement problem, you lose everything in the same pot, and that's not helpful. So hopefully I didn't go too much over time and you have understood something of what I said. Thank you.
Thank you, Valia. Now we have 3 questions from Osvaldo. The first one.
Osvaldo was from before.
Ah, okay. So Otávio, Diederik, you asked first, but then you.
Yeah, I have a question. First of all, thank you very much for this fantastically clear talk, with which I agree completely, in the sense that I've never understood myself why there is this focus on the measurement problem that is so incredible for me from the beginning when I was working in quantum physics. So, and I agree completely with you that robust realists, or real realists, I would say, they should focus on what you called incompleteness. Well, this problem that wave functions of 2 particles already are in 6 dimensions. Huh? The problem where indeed Einstein and Lorentz, like you mentioned, also was. Now, the question I have is, and as a philosopher, you might be interested in this. For example, the fact that in the EPR reasoning, the incompleteness argument is made by making use of complicated reasoning, actually. Most people think that incompleteness means that you have to add variables, and the so-called hidden variables, or to make wave functions not being ontological. The second thing is true, I think, but there is something different, and it's not very well known. Namely, the incompleteness indicated in the EPR problem is actually the impossibility of quantum physics as a structural mathematical theory to describe separated systems, you see. And if you see that that is the incompleteness, then one can understand, I think, why physicists have not advanced anything in solving something like that. Because the focus, if you look to John Bell's article, where he introduces the Bell inequalities, the first sentence is, now that we know that quantum physics is not complete, and we have to add additional variables. And this is a logical fallacy, because actually the EPR problem, the EPR reasoning is reasoning ex absurdum, logically speaking. And what is also something amazing, I was following your talks, your very nice analysis, and I think that we can say that the thing that Massimiliano presented, that we are robust realists. And I would like to have your opinion about that, but we cannot figure this out at this moment. Eh? Later we could talk about that, perhaps. I think we can claim in your classification to be robust realists. I don't know what Massimiliano thinks about that.
Well, very rapidly, the only point I'm a little bit, I don't know what to think, is that it seems that to be a robust realist, one need also to believe that physical reality has to be fully inside the three-dimensional physical space.
But wait, Massimiliano. No, I think it's enough. I asked Valia whether she would agree with that. It's probably enough that you can make a theory where everything can happen in 3 dimensions. It doesn't have to be represented by the wave function, but the processes can happen in 3 dimensions. Would you agree with that?
Me? Okay. So let me see if I understand. So you're asking, consider an ontology of processes instead of or anything just process. Yes.
Of dynamics.
Right. I mean, processes. Yeah. I mean, as long as you can provide a story about a dynamical story about how you get from this ontology to what you see and observe, this then you probably would call yourself a robust realist. What I was trying to challenge is that the wave function realists, the way they do that, they do not, I mean, they provide a very strange type of explanation. They go from the ontology to the observation in a way that I found not straightforwardly robust, but more similar to here are the principles, right, that are constraining the phenomena, right? So I was trying to distinguish between constructive or reductive explanation, right, which is clear in the primitive ontology idea. If you have microscopic particles, they, you know, like Legos, right, they build up the tables and chairs, right, intuitively so. Instead, you can just say no. I don't want that. So the Lego building block story is what I consider the prototype of a robust realist. I want the Lego pieces as my ontology. The wave function realists have a more complicated story in which they say, okay, there is this field, but somehow I can read off from the field tables and chairs. What kind of explanation is that? And my answer was, well, you're providing principles, right? Like in thermodynamics, right? Not all processes can happen, only the one that respect principle 1, 2, and 3, or whatever, 4, 5. So if you have an ontology of processes, right? How do you go from processes to, you know, what you observe is the one that are going to determine whether you're robust or not. Okay, so that's going to depend on the story that you tell.
Yeah.
Okay.
But you would agree, for example, that we talk to each other, we use language. That's a process inside three-dimensional space, no? We can be in the same room and talk to each other. We use words, use concepts, but it happens inside three-dimensional space as a process.
Yes, but okay, so I'm going a little bit out of my area of expertise, but what I was trying to focus on is not necessarily about how we explain, you know, stuff that surrounds us in general. I was trying to focus on what happens when you have a theory, right? And so that's why I'm kind of hesitant to agree with what you say. You say, of course, we use language, we understand each other and stuff like that, but what kind of, we are not using a fundamental physical theory in that example, right?
I should not take all this time, but we should discuss later, I think.
Okay.
I'm very interested what you really would think if I explain more in detail, but this will take too much time now. There are other questions, I think, no?
Yeah, you can write me. But
it was very enlightening for me, your analysis.
Oh, thank you.
Thank you, Diederik. Now, Otávio, please.
Thanks a lot, Valia. I also enjoyed your talk very much, and I thought it was very provocative and illuminating. So let me try something from a different angle.
Okay.
Because leaving instrumentalists aside, right, which I probably are hopeless, but I think anti-realists are as much of realists interested in understanding quantum mechanics and seeing what kind of picture it provides of the world. And in that sense, it seems to me that even an anti-realist should care about the completeness problem, the adequacy problem, and the precision problem. The difference is they can say, look, we don't need to posit an ontology to which we're committed to its existence in answering the problem. So I think addressing the problem is something that it's a common ground, or can be a common ground between both realists and anti-realists. The difference is what kind of ontological commitments the realists are going to require from their answers. Because, for example, I think an anti-realist can say, yeah, we need to make sense of the completeness problem. And we can get that understanding by adding certain things. Now, whether they exist or not is a separate issue. And it's unclear that we ever be able to establish that these things exist, because they go all beyond what can be empirically detected in any case. And it seems to me that's an anti-realist picture concerned with the completeness problem. What you're going to say is, well, at best, what we have here is a modal understanding. Quantum mechanics could be that way if there were such things. Now, whether they exist or not is a separate issue. So it seems to me then that it would be helpful to separate the problems and then what are acceptable solutions to them. And there, I think that's where the distinctions between realists and anti-realists will go, right? Of course, the instrumentalist is a radical case, because they say, look, I don't want to say anything at all about what goes beyond. So, okay, sure. Then they're not interested in understanding, right? But if you are interested in that, I think there is far more common ground between realists and anti-realists using your very helpful framework.
Yes. Okay. Interesting. So, yeah. Usually, when I think about anti-realists, I mean, first off, just go to the instrumentalist, and So, and I mean, I actually find what you were saying, like, the fact that they could. I mean, there's a branch of anti-realism that anti-realists who still care about understanding, right? That they may find some solutions of whatever problem useful. Are you? Yeah. So
Yeah,
I mean,
I
it
think
might.
von Frassen is like
Yes.
that. Right?
Right. Exactly. Or yes. Yeah. Okay. Sure. I mean. Yeah. Thank you. I mean, I was, you know, when you read a bunch of literature of certain people, right? You don't. But yeah, I mean, that's a very interesting way of going to it. Thank you.
Sure. Thank you.